So what is tautomerization? Tautomerization is the preference for a molecule to shift from an enol to a ketone. Now, why is this? This is because a CO double bond is a lot stronger than a CC double bond. And this comes from the ability of the CO double bond, the p orbital, to have more s character. Now, what do I mean by this? If you draw out the relative size of these molecules, an O atom is a lot smaller than a carbon atom, whereas two carbon atoms are of the same size. So if we were to draw out the p orbitals of these atoms, which looks something like this, of course we're drawing it in the y-axis. The electrons here are a lot closer to the nucleus of this atom if you were to have electrons here, whereas in this carbon atom, the electrons are a lot further away from this nucleus. So these electrons they're in a lower energy state. So if I was to draw a relative energy diagram of these molecular orbitals, we have a CO, because we know an oxygen atom is in much less energy, and we have a CC. And if we were to have an overlap, you would have something like this, of an anti-bonding orbital of high energy and a bonding orbital of low energy. But if two CC orbitals were to overlap, you would have a bonding orbital of low energy, but not as low as the CO double bond overlap. And you would have an anti-bonding of low energy as well. But again, would not be as high as the anti-bonding of the COO double bond. And so this lower energy state is much preferred by the molecule. Now let's look at how this happens in solution. If you have an enol in presence of an acidic catalyst like hydronium, I would use, this hydrogen is going to be deprotonated. Of course, any of these hydrogens are of equal chances of being deprotonated. And a reversible reaction and then a water molecule is going to deprotonate this alcohol group, leading to a final product. Thanks for watching, and I hope this helped.